Harry made a comment, just like React Native pass by properties. All right, guys, we'll see you in 20 minutes. All right, we are back.
I'm here.
Good. So there is one disadvantage I have at this too, that in a classroom I would know if people are back or not. Over here, please, here. Okay, I can see that few of you are here. Good. So what I want to do right now is open the floor for questions before we move forward. This is for most of you, this is the first time you're looking at Swift UI. Do you have anything that you need clarification on? Just looking at this, is it becoming clearer how this whole thing is working? If you have questions, now would be a good time, or even later you can ask if something is not clear. You can bring it up and we will go over it again. This is basically going to be the new way of doing things. So any project you start, a new project, you'll probably end up using Swift UI. Depending upon where you work, they may standardize on it as well. So it is good to have an understanding. Okay.
I have a question about
Yeah.
this format. So we have var body. Can there only be one body inside a content view, or can there be multiple bodies? And it does body means like all the views that are presentable in one
So
screen?
very good question. So as you will see that this content view,
Mm.
whatever is in it is being displayed here, right?
Yeah.
So, and what is in it is this variable called body. So without knowing internals of how exactly it is done, I would look at it and I would say that Swift UI expects each struct to inherit from some view. So it is of type view and it must have a variable inside which is called body, and it's the body of that view that is displayed here. So my answer to your question would be that if you have another variable which is not called body, it probably won't do anything. You can have other variables, you can define views, but whatever is the variable that is called body, which inherits from view, some view, which is of that type, that is what is displayed here.
So if we define another variable called next body or body2 and with same type some view right under body, would it also be visible on this same thing?
Let's say body to, right? So what is happening here is, and let's give it just the text again, right? So this here, oh, I think, okay, I have a typo. I used S instead of X. So Shahrukh, what is happening is this view builder, whatever is internally processing the Swift UI code, it says, okay, get me the content view, an object of this content view, this struct. And then it says, okay, what is the value of the variable named body in it? And it displays it here. Any other variables, they are not going to be showing up. However, you can create complex views. You can create a variable like this body2, and embed it here. I haven't done this before, but I would venture out to say that if I put body 2 here, it will show up, see. So I can embed this, it showed up here, hello again. So this is like any other variable in a class. You can define variables, you can break your view into multiple components and put them together like this. So we have,
So this acts like a function now.
it acts, well, actually, yeah, like a function, but it's actually a variable. We are just saying put this variable here. Yeah, like a function. It basically, like a function call, it will replace wherever you say body 2 with what is inside the body.
Makes sense.
Good question. So this is something you may do actually. Let's say you want, you want to break your view has many things, right? You may have a list here, may have some, like we see those master detail views. You might have some arrangement like that. You may break it up, you may populate it differently. This could itself be in another file. This body too, you could have it in a completely different file and bring it from there. You just import or use that struct here. So I'm going to leave it here as an example. So you know what this is. We did that. Okay. How about the alert? So this is where we left off. We are passing it this variable, the state variable, and this is going to create a binding between the alert and its source of truth, which is here. So how do we display an alert? Anybody did that? Anybody want to share?
The way I did it is here I just created an alert. So if you type alert with capital A, it will give you a default uh, uh, one, and you just fill out the content, and it will
Yeah.
basically.
It is as simple as that. Just like in JavaScript, those of you who are familiar with JavaScript, the way you create an alert is you just alert, it's a function call, it takes one argument text and it displays it. So in the same way here, alert will create an object, a new alert object, and these are the various options. You can have an alert which just shows the title. You can have one that shows a title, a message, and a button which allows you to dismiss it. You can have an alert with multiple buttons, a primary and a secondary button, and so on. So what we will do is we will choose let's choose the second one where we have a title, a message, and a button that will display. Okay. So you will see when you do this, it gives you placeholders and it tells you the type it is expecting. So alert title is expected to be text. Make note that it's not string, it's text. And what is text? Text is like this. It basically creates a label. So we need to do that here. It's expecting something that is text. So we'll give it a text and we are going to ask for some sort of confirmation from the user. And you'll see message itself is an optional, meaning, those other options, other things, other constructors it showed us for the alert. Let me just show you again. These. It is an optional because, you have an alert which does not take it. So you could leave it blank and nothing will show up. You could just pass a nil here. So for us, we will actually create a text and ask a question. Whatever question you want to ask. Let's say delete this file. And then the dismiss button. Well, actually, if we are asking for a question, we should have two buttons giving a choice, yes or no. But our app is going to be a still a little strange. It will just give one choice and you have no choice but to delete the file. So the way you add a dismiss button is actually, let's look at the documentation of the alert. So, we get more details. Swift UI alert. So there it is, alert. So creating an alert takes, this is what we saw, it takes a primary and a secondary button or a dismiss button. So our alert will just have the ability to get dismissed. And this is of type alert dot button. So what are the options available to us? So the options available to us are we can have a cancel or a default, destructive. You're welcome to look into it, more details. What we will do is we'll use a default button type. And the way you do it is, see, it has a pre-declared, it's expecting an object of type alert.button. So whatever is inside it, these are all static, you see. So whenever, and you will see this time and again in Swift, that you will see values that start with a dot. That's what it is doing. Whatever type is expected. So instead of having to say alert dot button dot default, you're just saying dot default. That part is implicit. The type is already there. You don't need to type it. So this is one of the things that Swift does, which is different from Java. In Java, you would actually go and type alert dot button dot, and you'll get all those choices, the same choices. So this code is more verbose. Instead, Swift lets you skip this because it assumes that if you just start with a dot, you're referring to the static variables from whatever type is expected. So we'll go with default and see what is it expecting. It is expecting an argument of type text. So once again, we'll just say text. Okay. Okay. So far so good. We have got now a button which shows the text and it will show an alert. Run your code and see if you get an alert when you click on it. Thank you, Michelle. We'll see you in the next class. Okay, anybody seeing the alert? Okay, maybe Shahrukh, you're a little bit ahead. What about the others? You should not be seeing an alert because our code is incomplete right now. So what is going on is, see, and this is the other thing I wanted to show you. In Swift UI, this is a preview, but this is non-interactive. To make it live, to basically interact with this, you have to press this button, live preview. So Once we go into live preview mode, it allows you, it will do things what that are supposed to happen when you interact with it, the gestures, the clicks. So I click on it, you can see that it's getting clicked, it blinks, but there is no alert. Okay. That's because our is presented default is false. What we want is we want that to become true when this is clicked. And that is the part we need to do here in this action. This argument action, it takes in some code. This is like a inline function. So this is where we will say that make this is presented, make it true. And since it is an outer element, we just have to say self dot is presented equal to true. Okay. Once we do that, we should be all set. We should get an alert like so. So are you getting an alert now? Okay. So Hamza, you're not getting an alert even though you added this. Okay, you are getting an alert. Perfect. So question for you guys. So we changed, see, when we tapped on that button, we said, okay, make this argument, this state variable from false to true. So now I clicked it once, we made it true. Why is the alert not here anymore? Where is it becoming false again? Basically, this variable tells us if the alert is showing or not. So now it should be false. How did that happen? Anybody?
So I think it's probably you click on the what they call it the default button. If you click on that, I think the button itself will set its present to the false.
Yes, that's correct. See, that's why we passed it. This binding business is for that. And we passed the reference here. So what this alert, this modifier, the view modifier called alert, what it does is it toggles the value of whatever you gave it here. That's what, or it sets it to false actually when you dismiss. And we can look at that. Did we have that documentation for button view modifiers, right? Button view modifiers. Let's find alert. Alert. There. Presents an alert to the, this is the one we are using. We are using is presented. Something else that is interesting for you to know. Look at the declaration here. It says alert and it takes in two arguments. Is presented, which has a binding to a variable that you are passing. And the second argument is called content, which is basically an alert itself, an alert object. So it has two arguments, right? Is presented and a content. What do we have here? We said dot alert. We have only one argument. What happened to the second one? And as far as we know, there is no such modifier which takes only one argument. The second one, this one also takes two arguments. This has something to do with Swift. What it does is, you see, this second argument is actually implicit now. The way we have done it, we have made it implicit by putting it as an inline function. You could very well just follow the same scheme as this. You could put an argument label called content and pass it, a function inline just like this alert. So for example, this, if we were to change to content and get rid of these curly brackets and instead have that, those two are pretty much equivalent. Missing argument for parameter content.
You're missing one extra bracket after dot alert. No, on top, after dot alert, you need one more bracket, opening bracket.
Oh, okay. No, I have to delete this bracket.
You can remove that.
Yeah. So this, see, those two are equivalent. Expected type. Maybe I have a syntax issue here. Okay, I think I'm not getting the syntax right, but that's the idea. When you have a second argument, and you will see this very often and you'll be puzzled. At least I was when I first saw this, that how come it does that? But that's its, that's what Swift allows. It's a little less verbosity of the code, basically. That's what they're aiming for. So anytime you have and this you will usually see in callbacks function call, that when you are emitting an event or something, you will just put an inline function block here, a code block. I think what I have to do is this. Yeah. So that's what it is. So I have declared a second argument label called content, and I have passed the same thing that was outside the function. And this will continue to work. So this is okay. This is just an aside on Swift, how it is doing that. Now let's see the details of this is presented. Presents an alert to the user. They haven't told us what else it does. But what it does is this variable, it will change its value to false when you dismiss the alert. That's what it is doing. So that's how it keeps on working. Okay. Everybody up to this point, you've got your alert showing. Good, good. What we want to do next is we want to show an additional view. Okay, this part we did. We want to do this now. This is our current view, and we want to navigate to another view.
Hello.
Yes.
I'm sorry, sir. Sorry to interrupt you. A quick question. In SwiftUI, do we have constraint layouts like we have in Storyboard?
Yes. So I think this is by default. It's working with constraints. So let's look at this. I'm going to open this, the attributes. As far as Hamza, from what I know, storyboards by default, if you don't have constraints, it uses whatever the location you give, right? There is only two options. Physical location on the device. So if the device type is different, it will show up instead of being in the center. And we saw an example of this last time that what was supposedly in the center, if your device is smaller, it comes off center, or larger, it will be off center. Here, I think the constraints are implicit.
Okay, so my question is like, if you want some element to be like 10 points from the top, and like we can do it in storyboard. I'm just curious to know like that.
Yes. So let's see. See, because it is always assuming that okay, this is what I think is happening. We can verify it. Everything is in a super view, whatever is embedded here, right? So we cannot have views here. Like when we tried, we added two text views without the vertical stack, and it gave an error. So everything is either in a vertical or a horizontal stack or a list view. And this V stack by default, we are seeing it is centered. So this is again, you can command click on the code side as well, and it gives you all the options. What I don't see anything here to, we can play around with the padding, but I don't see any other constraints here. Let's look up Swift UI constraint layout with constraints in Swift UI. Okay. Swift UI doesn't use layout constraints. So this is it. These are the kind of like what I was saying, that everything is either in a horizontal or a vertical stack. And actually there is a Z stack. You can overlay views. So basically that's it. There are no constraints. You can play around with things like, you can give spacing between the views through padding and all that. You can add spacers.
It looks something similar to HTML, like you have to like have everything inside divs, and then you adjust within, like something similar to that, isn't it?
Yeah, yeah, yeah. And this will be reminiscent of React Native as well, like Flexbox. Flexbox is in React Native, Harry?
It's in the React Native and React. So
Okay.
it makes the same idea if you give for example, the vertical stack. If you want the first thing at the top, but you have to do is like you have to list all the things. If you just list one thing, that will just automatically in the middle. But if you list all the things, that will automatically come to the top. So before you do anything, you just have a design like what you want. Then just automatically just add everything. Then that will go to the position you want.
So, okay, let's continue on that line. Let's say in Flexbox, I wanted these things to be at the top.
Yeah. So first you declare. So Flexbox, you actually can declare like you want star at the top. But if you don't declare you star at the top, you just manually add one by one. Then the first one will come to the top. So here, I don't know if we can set something like we want star at the top.
Yeah.
If we cannot, then we probably can manually just add everything. Then probably the first one will come to the top.
Okay.
Not sure. Yeah, but for the flag box, we can set up like you want start at top, you want start at like a top left. Because in the flag box we use like allergen atom, justify content, those two property to set up the where you want to begin. You want to begin at the middle, you want to begin at the top, you want to begin at the end.
Okay. So over here, it is behaving quite similarly. It is right now, it is doing that for us, and it is using its defaults. So my guess, Hamza, and let's look at this. Let's say we want to customize the VStack and place horizontal alignment. We're looking for vertical alignment. So it takes three arguments when you initialize it. Horizontal alignment, which is what we said here, it says center. And this you can actually change from here. You can change it to left, and that's okay. In Swift terminology, it's leading, center, and trailing. So, but that is as far as the horizontal alignment. How about vertical alignment? Is it possible to change it? Maybe it should be through, one of these. There it is, the alignment guide, vertical alignment. Sets the view's vertical alignment. So if we were to use this, we will be able to set that. So the answer to your question, Hamza, is that whatever we would do with constraints in storyboard, we'll do it through modifiers here.
Okay.
How about we add that as a homework? That seems like a good homework to make this box top aligned. To have the contents of VStack appear at the top. Just make a note of it. So I can add it to Blackboard. We haven't created any homeworks from this. Okay, perfect. So far, so good. We have got one view. In the storyboard, you want to, let's say, create another view and then add the navigation. What was our method? How did we do it last time? When we were doing the widget app, segue, we created a segue, and to add the second one, we just did a view controller, right? And we drag and drop it, and it creates an extra one, whatever it needs to do in the background, it does. And then we create segues. Here, see if you can find a view controller to drop next to it. Any luck? There are no controllers. So how do we do that? Let's say we want to go from this to the next one. How are we going to do that? The way you do it is and I could do it here from the folder. You right click on the folder where you want to create the new view, and you go with new file. And in the list, you will find the section called user interface, and you'll see Swift UI view. You want to select that and go next, and then it will ask you the usual questions. So where to save? If you right clicked on the folder, then you don't need to change that. And it wants a name. So let's give it a name. Let's call it page 2. It's being page 1. And the target, we want it to be a part of that app. So don't change that. Everything else is good. Let's create it. Okay. So this is how it does it. As soon as you created it, it is basically exactly what was in the content view, except for this name. Instead of saying content view, it says page 2. And if you do a preview, you will see what this looks like. So in the storyboard, you will be able to see them side by side, not here. Here we've got a separate, entirely separate view here, which again, it shows here in the live preview. So the question then is, how do we create navigation, a segue from here to that? And let's say we want to add below click me, let's say we want to add a link, a navigation mechanism called next page. So when we click on that, it should go to page 2. That's what we want, right? You guys want to take a few minutes, see if you can figure it out? It's 10:11. Let's take until 10:15. You have 4 minutes. Do your research, read, and then see if you can figure out how to add a navigation link from here that will go to page 2. Okay. Anybody there yet?
So we have to use a navigation view and also navigation link.
Yes.
That's the two thing I found out.
Okay. So how did you do it? Did you do it yet?
No, I just found out. Haven't tried that yet.
Okay. So that's correct. So basically what we want to do is we want to tell it that this thing, we want to embed this in a navigation view. So it will show up just like in the slide, you see. And this we did last time. We have these back buttons and the titles. This comes because we embed the first view. If we embed it in a navigation view, it gives us the sequence. Whatever follows it, any segues, it keeps showing the previous title as the back button. So if we, when we go from here to here, this title becomes the back button and this title shows here. If we were to go to the next one, because everything is in a navigation view, it is managing that process for us. So the next one will show this title as the back button, whatever its title is as the title. So that's one thing we need to do. We need to start by embedding this VStack in a navigation view. I don't know if it has like in the storyboard, it would allow us to embed in navigation view. Here it does not. So let's see if I can remember it. Navigation view. And then we embed this whole thing in the navigation view. Okay, so this whole thing is now in a navigation view. There may be another way of doing it graphically. I haven't explored. Anybody find that? If you can drag and drop or do something here. If you do find it, please share. But this is what it does right now. And I think we can give it a navigation title, navigation bar title. So this is one of the view modifiers of navigation view is navigation bar title. So we'll use this first one, navigation bar title, and we'll give it a title, page one. You see, we've got navigation bar title in this view here. So that was not difficult. We've got something set up here that takes, that allows us navigation. Now let's say underneath this button, we want to add a navigation, a link to go to the other one. Now in storyboard, you could have done a control drag from the button and it would allow the button to trigger the segue. Over here, there is an element of its own. Let's see if it is in the library here. Navigation link. Oh, there is navigation view as well. So we could have done a drag and drop. So navigation link is what we want. Let's place it here. So see, it appeared below that. And it wants to know its destination. So our destination is whatever is the name that you gave to that other view that you just created. So let's say page 2. And page 2 type cannot only struct. Okay. I think we need to instantiate an object. So that's it. You need to instantiate an object of page 2. And this is the text for this. The default is navigate. What does it take, Harry? Did you see that if it is just a string?
It just needs to be wrapped under text. So
It is
text.
text, right? It's a text. It's not a string like the title. So we just need to wrap it.
Yeah.
Okay. So we create that. Go to page 2. So let's run this in the simulator for a change and see what happens. Okay, so this is our view now. This should still show the alert, which it is. Go to page 2, went to page 2. Right? There is no title here, but it has everything else that we put. So now let's say we want to add a title here. It's the same mechanism as before. Over here in the body, you can go dot navigation.
You need to wrap that in navigation view first.
These two.
You can add a title. You can send title from the previous page as well. So where you wrote navigation link after the second page too, if you write dot and you can enter navigation
Okay.
in the previous page.
So from that one, right, you can pass the title to this one.
Yeah.
From what I remember, we could also do it here. I was doing it outside the body, but we have to do it inside. So let's try this. Page 2 and resume here. Navigation bar title is not showing. Maybe because in the preview, let me just double check what is going on here. It does show here. So you see, this thing itself is not aware of navigation because this is an independent view, right? In the storyboard, it knows all the connections in the background, that this segue is going there and all that. Over here, it is linked, but it is also a standalone object. So the way we did it is we added a title here, which basically takes effect whenever this thing has a it's embedded in a navigation hierarchy, navigation view in the flow. It will give it a title. If it is not, like here, it is standalone, so the title is not there. It does show up. Okay. So far, so good. What we haven't looked at, and we will look at it a little later in the course, is how to pass information. So for example, our app here could have been a photo gallery with thumbnails of the images. And any image you click, it takes you to the actual full view of that and shows it in page 2. To be able to do that, we would need to pass which image was clicked and what, to display the full size image for that thumbnail. That part all happens through this navigation mechanism. We'll come back to it at some other point. So in summary, what we did is we said whenever we want navigation, we have to embed the whole thing in a navigation view. We gave it a title, and when we embed it in the navigation view, it gives us access to navigation link objects, which are like buttons. So you see, it looks just like a button. That button and this, they have the same formatting, but this is actually causing the navigation. It knows where to go, the destination. Good. Any questions so far? Okay, no questions. Perfect. So this is where this was more or less an introduction to SwiftUI. Little little more than an introduction. We did a few things. So now we will move on to the next topic, which will bring us again back to our synchronization with Android sensors in iOS. Types of sensors, it's very similar to Android. Main types are, they're virtually identical. Motion, position, environmental, these kind of sensors are available to us. And to do an overview, I have put a link here to the documentation. We are going to open it. Core Motion. This is the framework. It's called Core Motion that gives us access to the sensors that your device has. So the main sensors there, accelerometer, the gyroscope. Accelerometer measures the forces that are acting on your device. So the gravity and any other acceleration, if you're moving the phone, all those things are measured by the accelerometer. Gyroscope measures how your device is rotated, tilted. Pedometer. This is, in some of these, just like in Android, they are over there, the terminology was software sensors. Here they call it processed sensors or processed events. So the pedometer may not be a hardware sensor, for example. It knows that you're moving in a certain way from the accelerometer and the gyroscope, and it can compute your steps and all that. And environment related events, just the same as Android. There is there is an ambient light sensor on iOS devices as well. Many those of you who use it will know that. And also the magnetometer and all those things are there as well. The pressure sensor, the barometer. And as in Android, you remember we had a class called motion sensor manager. Here, Apple chooses to call everything motion for some reason, even for things that have nothing to do with movement, core motion. So there, what is sensor manager in Android is motion manager, CM, and this is again CM motion manager. Why is this naming? Anybody know? CM device motion, CM attitude. This CM, so this is Apple's way of naming. So if it's something is a part of a particular framework like core motion framework, all the classes in it will have they'll start with this abbreviation CM, CM motion manager, like that. If you are using the MapKit framework, all the classes will start with MK. In the UI kit, everything starts with UI label, UI image. So that's their naming convention. And the motion manager gives us access to different types of sensors: device motion, attitude. Attitude is not the conventional way we say attitude. Don't show me attitude kind of attitude. This is just the orientation of the device. It's got nothing to do with the device being nasty to you. So accelerometer, same things as we saw in Android. You have access to all of these different. This is an interesting one, altitude. This uses the barometric data to sort of detect how high up you are. Okay, that's an overview of this. Let's see what we can do with it. Before we do that, let's also point out the differences we have from Android. So on Monday, when we did the Android app for sensors, we used the light sensor. In iOS, they don't expose the light sensor. I wanted to do the same exercise that will use the light sensor and change the mode. Unfortunately, they have not exposed that. So they have it available. Obviously, Apple uses it for the device. If you go outside, your screen will become brighter. At night, it will dim. All of that it does because it has a light sensor. People who have figured out that it's a private API and you can use it. If you use it, you're absolutely rejected from the store. So I don't see the point in us doing an exercise which you can't really apply. So I'm not going to show you how to use the light sensor because Apple doesn't want us to use. And it also, we've already done the light sensor for Android. So we might as well do something new. So what we'll do is we'll use the magnetometer to learn how to use sensors. That is going to be our basis. So we will use this particular sensor to get an understanding of how sensors work, general configuration, how to access the manager, how to access the sensor, how to start listening to the events, what data comes in, how to use it. All of that we'll set up with this magnetometer. So what we'll do is we'll build it on top of what we have done so far today. In that page 2, we will add the functionality to listen to the magnetometer. Okay. And what we'll do is that sensor gives us measurement of the magnetic field in 3 different dimensions, and we'll display that. So how do we do that? Okay, let's go here, motion manager. So anytime we want to use a sensor, we need to have an object of this class, and we need a place to house it. So how will we do it? We'll go to our page 2. Okay, so this is where we have the view that is getting populated. And what I want now is I want this particular here, this view to, let's say we want to add the X, Y, Z, the 3 values for the magnetic field below it in a stack. So we'll do that. We'll embed this in a V stack. And we will add 3 more texts. Okay, so we've got this, and what we want is the value in the X, Y, and Z, the 3 directions. When I resume it, I should see that the X, Y, Z appear here, and that's it. But how do we get those values? And we can do it here in this file, or we can create another file, and we need a class to manage that functionality for us. So let's create a class called, let's call it motion processor. Okay, and inside this is where we'll do all the functionality. This is the class where we'll manage. We'll have an object for the motion manager, the CM motion manager, and we'll create an event listener so that we can listen to those events, and then somehow pass those values here. This is going to be our objective. So let's create a variable. So it is not giving me motion manager, right? Any idea why?
Maybe you have to import it.
Yes. We have to import core motion. And as soon as we have done that, we should see motion manager. So we've got an object to the motion manager. I want to get us more information. Let's see if Apple has any code examples that we could use. Microsoft also has. So you will find from time to time Microsoft results for both Android and iOS. They've created their own documentation. Okay, but this is for their cross-platform framework that Microsoft uh, Xamarin. Do you guys learn that as well in your cross-platform dev? Have you learned this framework? This is like React, but obviously different syntax. So this documentation is for that. We are not interested in it. What we want is looking to get okay. So generally speaking, this is what you would do. You will instantiate your motion manager and you will have a function that is going to basically set up what you want to do. So is accelerometer available? This is just a courtesy check if the device has it or not. And then you start setting up that this motion manager, you're telling it that, okay, I want to listen to your accelerometer updates, and this is my interval. How many times? 1 by 60 hertz, so 60 times a second. You want to listen to it. And start accelerometer updates. It starts receiving the events. Here it is not very clear how it is doing it. But anyway, since see, we don't have a function and all, what we want to do is when we create this object, motion processor, our class, at that time, as soon as it is created, we want to set up the listening of the magnetometer. How do we do that? What is it that we need to do here? So in Java, when you are creating an object and you need to do some setup, where does that go? Constructor. Would it go in the constructor? Yeah. So, and how do we create a constructor in Swift? if this was Java, what would be the name of your constructor? Constructor is a function, right? Like any other function. But what would be the name of that function in Java if it was a constructor?
Class name.
Same as the class name, right? So how about in Swift? In Swift, your constructors, they're called initializers. They're always called init, and you can have more than one, taking different arguments, just like in Java. And there is a convenience initializer. So in Java also, if you don't have an initializer, the language gives you an empty initializer. You can instantiate an object with no arguments. Same thing is there in Swift as well. If you don't have it in anything, it will do it for you like that. But here, let's say we want to create our own initializer, empty initializer. And what we want now is we want to say motion manager dot magnetometer update interval. And let's say I want it 60 times a second as well. I'll do go 1 by 60. So that is one thing we need to do. We need to tell it how often to listen to. And the next thing we want to know is what happens when there is an update. Right? So for that, there are these methods. Start updates. So start accelerometer, device this, device that. There is one called start magnetometer updates. So let's use that. Start. And this is something you can call it without arguments, then you need another way to tell it what happens when that update is received. What is the callback function? Or we can just use this, the first one, and call its, this handler. So let's do that. Let's use the first one. So this is what will happen when an update is received. It is going to be on a certain queue. Operation queue is like a thread. Which thread is it going to run on? So you can run it on a new thread or the main thread on which the event is received. Like before, if you just press dot here, these are all static variables you have access to. If you press dot, you will see what your options are. You can either create a new thread or you can use the same thread. So we'll go with the same thread. And handler is, let's see, it takes certain arguments. Magnetometer handler. Okay, this is where I would have to refer the documentation. So start magnetometer updates. It's basically a handler. I think that it takes two arguments or at least one argument, the data it is receiving. And then within it, we have a function call. Okay. Stack Overflow is our friend. We'll go there. So how to output magnetometer data using SwiftUI? Okay, so this is it. So this is what we are looking for. Our thread is the main thread, and this is our handler. It takes two, is it two? Yeah, magnetometer data and error, and then it does whatever it needs to do inside it. So that's what we need here. We need to define the handler. Right now, we could just do it like this. This would be an empty handler, but we know that it takes two arguments, right? So let's call it this. And what does it do with this information? So again, this is Swift syntax. It's declaring an inline function and it is receiving two arguments. What is your problem? Okay, I have to say in. So basically, these are the arguments it received, and we are going to do something with them here. What are we going to do here? What we want is we want to read the let me just extract, right? So let x equal to what are the values? So we are at 1046. Okay, you need to access the magnetic field object of the data you're receiving and then x, y, z. That's what you need to do. So that is what it would have been, magnetometer data dot magnetic field dot x, right? And we can display it here. So this is string interpolation. I don't know if you're familiar with this syntax, but it will print that for us with a warning. You can fix it. It will give you some options. So that's an optional value. Okay, right now it won't do anything. We haven't instantiated this object. Let's instantiate it here so that we at least and then we will see, we'll stop there. Motion processor, right? So we have this, whenever page 2 is created, it has an object called motion processor, which is this. And what it does is it creates a motion manager object, starts listening to the magnetometer and starts receiving the updates. And that's when it prints. So if I run it now, I should start seeing in the output here the readings. Let's go to page 2. Okay, that didn't happen. Anyway, I don't want to spend more time on it because this seems to be a logical point for us to stop. The idea is that this thing should become familiar, that you access the sensor manager, start listening, and then do something with the data that is received. So next week, what we'll do is we'll figure out how to pass this information here, the data that is being received, to these text views, how to bind them together. That's where that binding concept that we looked at will come in handy. And that requires some other setup, like for example, this object belongs here. We have instantiated it, but when the view is displaying, we want these things to be aware of each other in real time. The view needs to be aware that this, as soon as this information is received, it triggers a change here. That is what we will achieve next time, and that is what usually you will end up doing with sensors. Okay. Any questions on this?